Hello, everyone, and welcome for another RavenDB webinar. I typically use this webinar to talk about new features, exciting things that we are doing, and stuff like that. And it occurred to me that I've been so versed in the new stuff that we are doing, the bleeding edge, that it didn't even occur to me that to give you some context about what are some of the best ways to utilize RavenDB. I actually have quite a lot of webinars that discuss modeling behavior and overall architecture, but I actually wanted to go back all the way to the start. I used to build applications. I used to be an application developer. I like to think I was a pretty good one. Only in the backend, I would admit quite plainly, my UI skill sucks today, they suck then, and probably always will. But I built backend systems, business applications. And at some point, I realized that the transition from being the person who built the system to being the person who fixes performance problem with the database. At the time, RavenDB didn't exist. I wasn't actually aware that NoSQL existed. So I wanted to guide you to some of the most important aspects that led to the way RavenDB is. And many of those features are still core concept in RavenDB today. So the topic that I want to talk about today is a little bit about code, mostly about how you approach building the system. And there is a pretty well-known eShop sample application from Microsoft that showcase how you build a .NET application. And this is what it looks like. And I really like this system because it takes clone the system, hit a 5 inside Visual Studio, and you have a running system. So from that perspective, it's very well done. Now, this is actually using Entity Framework and SQL Server behind the scenes. So look at the user interface. Can you tell me how many queries we have to render this single page? So let's see. I'm assuming that here we have a list of all the brands. This is a query. And now this is probably another query. Oh, this is another query. Yeah, okay, it sums up all of the basket items. We have to get the total count of items in the catalog. And finally, we have to get the most recent items from the catalog, or the top page or something like that. For fun, there is no order in here, so we get effectively random ordering. So look at this. 5 queries to render the home page of a trivial sample application. And that's nothing. My record is looking at the number of queries to render a single page, and that number was 17,000. And I remembered I had no idea how to even process that. That was some really sick application, and not in a good way sick. So what's the story? What's going on here? Well, we need to go and get some data from the database. And in a relational system, all of those items are sitting on different locations. So you have to make multiple queries. This one is especially offensive to me because this is the same data set. So first, gather all of the items, then gather the top 10 items. Now, in this case, this is actually really, really easy. But what happens if my query is show me all of the orders so show me all of the catalog items that can be shipped to my location? Well, now this is a much more complicated query. And that means that I have to do more work twice. Absolutely insane. But even that isn't such a big deal. Here's the problem. The biggest problem that I ever run into. Latency isn't zero. What does this mean? It means, by the way, I haven't said that. I usually said it in the beginning. If you have any questions, you would like to have a conversation instead of just me talking to the screen, I would absolutely love that. You can raise your hand. You can you can use the Q&A button to ask questions. I would answer them live, and I'm very happy to do so. So going back to latency isn't zero. What does it mean? When I'm developing a system, I'm typically doing that on my local machine. And I have a local database and a local application. Everything is local. And the amount of time that it takes me to reach the database is minuscule because it's in the same location. What happens when I go to production? Well, when I go to production, I'm moving to a application node and a database node. Sometimes they are on different availability zones if you're running in the cloud, different regions. The latency, the time that it takes from a network perspective to reach the other side is absolutely ludicrous. Let's assume that it takes 1 millisecond to do an actual query, but it takes me 5 milliseconds to actually reach the other side, to actually go to the database and come back. And this is not a high number. What this means is you can see here the division of timing. This is the amount of time that is spent actually in the database. This is just the time that is spent getting to the database. Think about this in the same manner as going to the grocery store. Here I have a cup of coffee. In order to make some coffee, I need coffee grounds, I need milk, I need water, I need sugar. So I go to make myself a cup of coffee. There is no milk. I have to go to the store. I come back, start preparing a cup of coffee. I have milk, I have no sugar. I have to go back to the store. And then I have no coffee, I have to go back. So how much time I actually spent on the road to the store and back versus the time that it took me to make the actual coffee? That's a huge problem. It's a huge problem because during development, you typically don't feel that. And this seems like a really silly thing. Like I'm being nitpicky here, but it actually has a huge impact on your system. RavenDB is a really fast database, but then you realize that we are still subject to the law of physics, to the speed of light, and to network latencies. But it turns out that you don't have to go to the store each and every time. You can make a shopping list and then go to the store and get the details. Let's look into that. This is how I felt. I mentioned the 17,000 queries, and that was a big outlier. But it is actually really common to get into situations where you're seeing dozens or hundreds of queries to render a single page. And as the amount of users grow, the amount of page views per second grows, the number of queries that you have hit ridiculous numbers for pretty much no reason. And your latency suffers, and your load on the database suffers, and all of those sort of things. So when I sat down and built RavenDB, I knew that I wanted to handle that. So here is a trivial example. You can see here that I'm doing a page query. Probably the most obvious scenario for business application. I want to show page data. You do that 100 times a day, and you build the application. So you need to do two separate queries in SQL. In RavenDB, you send the results to the server. You send the query to the server, and this is what you get back. In particular, look into this. I have the total results value for my users. You don't need to ask it. You don't need to make another round trip. You don't need to pay again the cost of the query. I had to compute that as part of executing the query anyway. I might as well give it back to you and you can do something interesting with that. For example, not go to the server. And that means that if you're talking about RavenDB versus SQL, SQL needs 5 round trips to do that, and RavenDB needs 4. And that's the only change the only difference that we have. Now, it means that you have to use a dedicated API, which is get statistics. But we'll touch on that in just a little bit. Now, here is another aspect. If I want to render the issue page, I have to get some data from multiple locations. There's actually several ways in which I can do that. I can say, hey, all of my drop-down list should be in a single document that I would load. I can do a whole bunch of things, but you know what? I don't actually need that. Because look at the kind of code that I have here. And let me explain what's going on. So the whole idea is that I'm saying, give me a query on brands, give me all of the brands, but do that lazily. This line returns lazy task because we're using async session in this case, and it does not generate a query to the server. In fact, all of this code doesn't generate a query to the server. And here, for example, you can see that I'm saying, hey, I want to get the statistics, including the number of the, and here are the statistics about this. So duration, total results, etc. So give me the statistics on the query. And again, do that on a lazy fashion. None of this goes to the server. The easiest way to think about this feature is that you add that to the grocery shopping list that you have on the fridge. And at some point, you either access one of those values or you explicitly say, execute the lazy operations. And then we effectively take the grocery list that we made, go to the store one time, pay the single server round trip in order to do that. And now all of those are here. And that's actionable and immediate, and it's easy. And that means that we went from having 5 round trips to 1 round trip. And if you think about this, this is a really insane impact. Look into this. Now we have this, the time to query remains the same. But now I have 5 queries and 5 millisecond round trip. It's not crazy. It's reasonable. But there's another aspect here, which relates to the manner in which we're actually doing operations. Let's look here at a database and let's run a query. The orders were shipped to, city is Paris. And I get a result. And that's great. That's nice. Except that I actually need to render the employees, the employee names or something like that. How would I do something like that? Let's do a naive implementation. And I'm going to start from scratch. A session. And I'm doing something like this. Oh, to list sync. Now I'm doing this. Now, if I want to get to render all of the orders and the relevant and I want the employee. Here we go. Now, here's a problem. What is the number of database queries that this is going to generate? This is called the select n+1 issue. Why is that? Because here is a select, I get 4 results back. Now 1, 2, 3, 4, 4 additional queries that I'm going to have to make. And remember what I mentioned about latency being a killer. And there are all of the studies about latency being so important. What does it mean? Well, it means that if latency is a killer, then adding another 100 milliseconds to my page means that I'm losing my audience. And there has been study there both by Google and Amazon that showed dramatic numbers around that. Now, I can also do this. I can ask RavenDB quite explicitly. Also include the employee. Now, this is a stupidly simple feature. Why is that? Because what are we asking RavenDB to do? It says, hey, I want you to get me the employee. Look at the employee field. This is going to be a document ID. And I want you to get me the related document ID as well. And this is what happens. So in one round trip to the server, I got both the results of this query and the related data. In code, this looks like this. That's it. I'm done. What happened? In one round trip to the server, I got both the results for the query and the related objects. They are stored in the session. This thing is guaranteed to not send a remote call. The cost of this is now 1. And that is an insane impact. An insane impact on the way your system behaves. And we have a questions from Parabels. The first time I came across RavenDB, I got the impression that it was only for C#, they had wrapper around C#. That was a big turnoff before I left the Microsoft ecosystem a long time ago. I don't have any plans to return anytime soon. Well, I think that at this point we have official clients for something like 8 or 9 languages. So let's take Node.js as a good example. And this is the demo application that we have. And you're going to see that I think we have just a few of the support languages here. But here you can see I'm using Node.js to operate on RavenDB. For that matter, from your perspective, you're never actually aware of how RavenDB is running. You don't need to install the Node framework. You don't need to manage that. RavenDB runs on Windows, Linux, Macs, from a Raspberry Pi all the way to really crazy cloud instances. And all of that gives you the same experience of not having to deal with a lot of this. And here is the example of doing an include. Or in this case, this is a more complex include because what we are actually doing is including a nested object inside of an array. I hope this answered the question. If not, feel free to ask some more. So at this point, what we have seen is that we have the ability to massively reduce the amount of time that we spend over the network, which sounds like a really silly thing, but it has a huge impact. Now, I spend a lot of time optimizing RavenDB. We actually have a team of people whose sole task is make RavenDB faster, or as I like to call it, I want you to make the code uglier. And if you go into the code base of RavenDB, there are some amazing ugly code which is meant to be stupidly fast. And even so, even with a decade plus of optimizations, this sort of thing, reducing the number of round trips, is still one of the best way to reduce the amount of operations that you're doing. And because this is such an expensive thing, RavenDB comes with a built-in knob that will tell you, hey, there is a problem. If a single session executes more than 30 requests by default, we throw an exception and tell you, hey, did you mean that? We are careful to make sure that you have a way to turn it off, including production, etc. But the whole idea is that we want to make it clear to you that something is happening, even if it happened behind your back because you have something more complicated like that. We have a question from Nemanje Tosik. I hope I'm pronouncing that right, and I'm assuming that I'm not. Hi, Oren, do you have an example anywhere of using the include approach alongside DDD repository pattern, where one query includes an entity for multiple aggregate roots across what is usually a couple of repositories? And the answer is, wait just a little bit. I don't know if you will be happy because I think that repositories are a really bad solution. I will expand more in just a little bit. And we have another question from Parbels. RavenDB and GraphQL, if I understand what you're saying, RavenDB does what GraphQL does, but at the database level, unlike GraphQL, which does it at the API request. The whole point behind GraphQL was to reduce the latency, reduce the number of round trips. The idea is that you expose a GraphQL endpoint to your user, your mobile application, something like that. If you are operating in this manner, then it makes sense that GraphQL is a great solution for that. But from your application to the database is also something that you have to think about. Sure, in many cases, you have to deal with lower latency because, again, the application and the database tend to sit close together, not half a world away like you might have in a mobile application. But this is still measurable impact. And when you're dealing with, I have to count the number of milliseconds on the P99.9 in order to make sure that I hit my SLAs, that's a huge impact. And what RavenDB allows you to do is to reduce almost to a single server round trip across a wide variety of operations. And we have another question from Hong. How about attachments? If an attachment have multiple if a document have multiple attachments, is it possible to load all of them in one round trip? And the answer to that is yes. I don't actually have you have the get attachments command, which is, here you go. So the way that you do that, what is attachment request? Okay. So you can do it like this. Advanced attachments, get, and now you can do and this is not it. I think that this is okay. So this is the document ID, and this is the and something like that would do it for you. So again, the whole idea is that we reduce the latency, we reduce the number of queries. This is something that I feel very, very strongly about. Again, because this is one of those things that happened a very long time ago. Those design decisions go back a decade plus, but they still have an impact today. Okay, so let's talk about the other side. A big reason why you may want to shift your thinking is how you model the data. So let's talk about this for a second. In a relational database, you spend a lot of time moving the data around between relational and domain thinking, between how the business is thinking about the data and how you actually store that. This is called the impedance mismatch. And this has several different aspects that you have to deal with. One of them is the amount of code that you have to write. Second is the amount of work that the database has to do in order to perform your queries and operation. And finally, and this is an absolute killer, and this is the issue of the confusion that is inherent into the system. What do I mean by that? You go to a business expert and you tell it, I'm sorry, this is really annoying. I cannot live like that. It should be like this. Okay. Yes. So what the hell? At some point, I have to stop relying on Copilot to generate code for the presentation because it absolutely drives me mad if I see something like that. Anyway, so the whole idea is that if you go and talk to a business expert and you're going to try to model the data and it's suddenly 70 different tables to represent a single domain concept, there is no way that you can expand them to that. So you have to have a boundary, someone who would translate between the technical details to the actual implementation aspects. And a great scenario here is the notion of basket item versus basket. If I'm talking about the relational database, and you can see it in here, I have a list of basket items that belong to a particular buyer. And that's okay, that's what I want to have. But this is actually independent values. If I wanted to have an actual basket that has line items, which is how you typically model an order, for example, well, that is much more complicated. With RavenDB, I would typically have the notion of a basket as a complete document. And then I have a list of items inside that basket. And if I wanted to get the number of items in the basket, I would do something like this. Because otherwise it wouldn't make sense. And that also leads to another issue. If you're following DDD, and like the question that I said I would answer later, if you're following the domain-driven design concept, you have the notion of an aggregate root, an entity, and a value type. And those are non-trivial concepts. In RavenDB, you don't actually have those many levels. You have an aggregate root. And everything else is just inside a document because the document is an aggregate root, which is very important for modeling consideration. And now when you go and talk to the business, you're going to be talking to them with the concept of documents, of forms. And if I know anything about business, is that they love the bureaucracy, they love the paperwork, and a form is something that makes sense to them. So this is what we want to have. This is how things are actually happening. And let's see how we actually look into that in detail. So this is the model that we have for the eShop web. This is how the model thinks. Notice that I'm looking at the code structure, not the tabular structure. I don't actually care that much about this because I want to see how I'm working that for my application. And I have an aggregate root interface and a base entity, and I have an order item which belongs here, but it's not an aggregate root because it's wholly contained inside an order. I have an address which is effectively a value type that is inside here as well, but sometimes it would be a reference or something like that, and things become a lot more interesting. But this is a relatively classic way of doing that inside of RavenDB, inside of a relational database. When we're talking about RavenDB, we're talking about a completely different approach. Look at what happens. A document is a complete aggregate. We may have a reference to the outside world, but those are reference to other aggregates. And if I have nested items, they're here. If I have value types, they're here. I don't have to go and seek out additional details. And for that matter, there is also a huge impact on what it means from my perspective. I don't need to go and try to figure out how do I reconstruct this business entity from so many different tables. At runtime, I'm not asking the database, let's do a join between 6 different tables and feed that into a correlated subqueries just in order to get some of the data out. At one point, the query that I needed to run in a big system just to cover all of the complexity was over 200 kilobytes. That's the query. That's the sort of thing that if you need to touch it, you meditate. And that also leads to another aspect. It's costly to go to the database. And I have to do a lot of work at the database layer. So what would you do as a good developer? You would put a cache in the middle. Let's not go to the database. Let's not reconstruct everything. I can just use a cache. And there is a well-known statement that there are only two things that are hard in computer science. And this is naming things, cache invalidation, and off-by-one errors. And this is exactly the thing. The moment that you add a cache, you have to deal with that. How do you invalidate that? How you make sure that you have some level of consistency? But I will touch that on just a little bit. I want to give you some idea here. You can see here the eShop web is a DDD application. It uses repository, it uses specification, all of those sort of things. And you can see here how they define the approach. And I'm looking into this and I'm going to say, hey, that's really interesting. I can see that here is the query, and this is where it looks like here. And then I'm doing an include, just like RavenDB, right? And include on another value. But if I'm looking at the query, I can see something really interesting. Here is the effect of the include on other items. That's great. That's exactly what I want. And now I have another include, and that's something that I'm kind of worried about. Why is that? Because now I have 3 joins. Do I have to start worrying about Cartesian products? But I don't actually have 3 joins in here. I have just 1. What happened? Well, let's look into this. Here are the item orders, which is for this guy. And here is the table structure. What's going on? Look at this. I have duplicated data. Why am I doing that? Does it actually make sense? Well, I'm doing that here, but why would I want to do that in a relational database? It turns out there are two typical reasons why you want to do that. One of them is that from a modeling perspective, you want to create a separation. Here is the picture URI at the time of the that item was ordered. Here is the product name at the time that this was ordered. That's one aspect of that, and if that's the case, I would say good for you. That's what you was expected to do. This is where RavenDB typically does that. The other issue, and the reason why this happened here, is that it's expensive to traverse tables. So it's cheaper to bring the data into my table, which ruins the total normal form, but at least it gives you reasonable performance. And now you can see how it looks like when I'm issuing the include for my code. In this case, by the way, again, almost everything in RavenDB is orthogonal, so I also have the ability to do an include with a lazy. And it's really important to understand that an include is not a join. It doesn't change the data model. Let's go back to RavenDB for a second. And here we go. And let's add another couple of operations, of includes. Here, all of them are coming here. Here, all of the shippers, the companies. Let's do London, it has more items. Now you can see how we got all of those results. And this is excellent. And this is excellent because I'm not modifying the data model. This query, regardless of how many includes I have in it, is always going to return an order. And all of the associated items are going to be pushed into the session from which you can be pulled out without contacting the server, which is insanely cheap. And that's really nice behavior. Now, let's talk about other aspects. And this is Nemanja. This is what I talked about before that I think that you might not like. This is a typically this sample application. We have the concept of a read-only repository, another repository, and then we have all of these specifications. And that's okay, but I want you to think about the amount of architectural overhead that this imposes. What do you mean by that? First of all, I have a repository of T, but I need to have something in my application that work with multiple types. I want to load the user and its associated orders. And for each order, I want to look at the relevant shipper. Do I now use 3 separate repositories? Well, they would have to share at the backend the same behavior, the same session, in order to benefit from features such as unit of work, from features such as include behavior, etc. Now, I want to take you about 20 to 25 years back. Martin Fowler published a really fantastic book called Pattern of Enterprise Architecture. And it's about this stick. And it composes a lot of fascinating patterns that allows you to build really good systems. You would find their unit of work, you will find their a model view controller, a whole bunch of really interesting things. And in many applications, we see people trying to model themselves based on those patterns. And this is okay until you realize that this book came out 20 plus years ago. And you know what happened in the past 20 some years? The landscape changed. When Fowler wrote those details, those patterns, you would typically access the database directly by writing direct SQL queries and manipulating record sets manually. So you wanted to uplift yourself to the level, you would uplift yourself to the level where you would execute on business concept details. But right now, if you use modern, not even modern, anything in the past 15 years or so, even before that, data layer, not something that you write, something that you get from the underlying framework and clients that you use. Well, let's look at RavenDB as a good example. The session is a unit of work. It implements all of these details for you. Change tracking, transaction management, all of those. If you use anti-framework, the same. Hibernate, the same. In the Java world, you're used to using JPA or Hibernate. And that's just something that gives you all of those behaviors. You don't need to write any of this code. And by adding additional layers of abstractions, you're actually making your own work harder. Now, let's think about this scenario. What happens if I want to make a change? I want to add another field to my query, to my filters. Well, you now have to go through multiple layers. You now have to violate both dry and SRP. Don't repeat yourself and the single responsibility principle. This sort of architecture actually make it harder for you to change things. I've been working in development for quite some time. First time I got paid to do development work was in the 90s. That means that I probably have 25 years of trying to build better software. And at this point, I've worked on projects from just me to hundreds of people. And the one thing that keeps you sane is to have a proper architecture and make sure that most of the code that you write is stupidly simple. If you keep it simple, you can sustain it. If you go to complicated architecture, this becomes so much more complicated over time. So what do I recommend? Take your queries and push them as far forward as possible. As I mentioned, I'm not a front-end guy. And there are reasons why the front-end should never issue queries. Because you need business rules, because security, a whole bunch of other things. But put your queries directly on the controller and use the session explicitly from there. You want to reduce your abstraction as much as possible because that allows you to focus on whatever it is that you want to do, on the actual business value. And that sounds strange to some people because what you're actually doing isn't working with low-level abstractions. You're already working with high-level clients and operations. Use them, don't drop them. Because when you need to make a modification, I want to add an include. Oh, wow, I add a single line of code instead of traversing 900 items. Here's a good example. I want to have some shared common query behavior. How do I manage that? Well, the first thing to notice is that even if the current query is currently identical on two endpoints, this doesn't mean that this is still conceptually the same thing. For example, I may want to show the recent orders on the home page and on the orders page. Same query. But the order that show up in the home page may be something that I want to address. Maybe I want to show in some other point, show me the recent order past month, but sort them based on delivery status or whatever, based on how happy they make me feel, versus the report on recent orders, which is completely different. The other option is, especially if I have complicated rules, is to package that into an extension method, like you see here. And now I want to get me all of the non-deleted posts with blah, blah, blah. That's about it. Now, I want you to pay attention to something really interesting. See here. Why are we making the query in this manner? I mean, I could drop this pretty big line and have much shorter system. What's the point? Well, the point is very simple. The idea here is that whenever I'm accessing a date, I have to consider at what granularity do I query. If I query on a millisecond granularity, that means that I have to take into account that every time that I issue the query, I'm going to be unable to use a cache on that. But wait, didn't I say that caching is bad because it's really, really complicated? Well, let's talk about this. What's going on? RavenDB does caching by default. You don't need to do anything. And you don't need to try to figure out how to do what's going on, whatever. The only thing that you need to do is, okay, if I'm issuing a query like this, let's make sure that I'm doing that at appropriate granularity, that two queries that happen at roughly the same, whatever granularity you have, would be able to take advantage of the cache. But how does it work if caching validation is so complicated? When you issue a query, when you try to load a document that you have done in the past, your RavenDB client is going to send the query to the server along with an indication, here is the last version I have of this document or of the result of this query. And there is an optimized code path specifically to answer, have something changed since that time? And if nothing changed, I can skip loading the document, rendering that, sending it to the other side, running the query, all of those things. I can just tell you, hey, that version that you already have in memory, just use that. I reduce the amount of time that I have to process the query. I reduce the number of bytes that are going over the network. And I actually even cheat further. RavenDB stored the cache in a parse state, so I don't even have to parse the JSON from the server. Everything is so much easier this way. We also have a feature called aggressive caching, which means that Raven, instead of me having to go to the server each and every time, the server will go and tell me, hey, something changed. You probably need to update that. So those sort of things are small features, but caching by default can have a huge impact on your system, specifically because it's by default. And you don't really need to think about it. And suddenly you realize, hey, if I'm using this approach, the amount of time that I have to spend optimizing the database goes down. Same thing for automatic indexes that RavenDB deals with, and a whole bunch of other features. And this is something that I actually want to address. For example, if anyone ever try to set up from scratch highly available relational database, just a SQL Server, MySQL, or something like that, this is not trivial. I'm being very gentle here. This is several days that you have to go with and test and verify that automatic failover working and everything. With RavenDB, we started from the basic assumption that there is no on-call DBA. There is no someone who would always keep the train running on time. That the server and the client are on their own and have to manage. So we actually have a really elaborate process behind the scenes to make sure that the clients are always aware on the failover topology. And when a client detects an error, it automatically fail over based on prearranged symbols and a whole bunch of other things like that. I have a question here that is saying, if aggressive caching updates the client in real time, why isn't it the default? And the answer is, it's real time, but it's not necessarily fast enough. So it's possible for me to make an update and query over this update and not see it because the update to say, hey, you need to, the information about you need to update the cache haven't been received or processed yet. So this is something that you have to explicitly opt into. That's why we call it aggressive. Finally, and the most important aspect that I have to discuss today is this thing. No on-call expert. No one is going to be there to save us if something happens, so we have to do it on ourselves. And one of the things that ended up happening as a result of this mindset is that we packed a lot of features into RavenDB that are not meant to be user visible. In fact, they do quite the opposite. They make you forget that we exist because we don't require a lot of attention. And it's funny because then you realize that a large amount of the design pressure on RavenDB is coming from that scenario. You build an application and you deployed it. And RavenDB makes sure that you deploy securely and properly and all those sort of things. And you don't have to configure high availability because it's just there and it's working. And then you leave to another project. And 2 years goes by. And now there is a problem. You're in a different role, different department, maybe different company. And no one knows what's going on because the system has been working. And I actually had a case recently where someone told us, hey, we've been using it for 7 years. That's the first time I'm hearing about it. So the CTO, because that's the sort of thing that gives you no problem. And that was an amazing thing to do because it validates the core design principles that you should get out of the way and have things working. And with that, let's see if you have any more questions. So we have an anonymous attendee who is asking, is every query result cache or just those that return single results? I'm thinking of very complex query that returns a list of documents. The cache is per query, and it's both on a single document and the query results, which may be multiple queries or something like that. The same thing applies if you're running on MapReduce operations, facet, everything is cached. And the reason this is working is that we're actually caching at a very low level. We're not caching at the level of entities or query. We're actually caching at the level of remote calls interactions. So I actually have a full webinar talk specifically about caching, how it works, and all of those design decisions. And I think it's really interesting because of what it impacts, but that's for another time. If you have any more questions, now is the time. And we have that. I'm so loving that there's a lot of questions. Yes. So if include won't issue a join, even if you're including an object from a different root, what does it do then? How does it pull the related item behind the scenes? And that is a great question. And I want to show you what it's doing. Here is the query. The dot include that I showed before, this thing or this thing, would be translated into something like this. Now we're going to issue this query, and instead of showing you the nice API, the nice UI, let's look at the actual results. This is the JSON that is being returned from RavenDB. And you can see here the results for the query. By the way, here are the total results that we needed. In addition to the results, and this is the thing that match the query, in this case, all of the orders from London, we have another channel. Here's employee 7A. Here is employee 7A, so I can look it up. And you can see here is company 11, etc., etc. So the whole idea here is that what do we get? We are issuing one query to the server, getting the results of the query, and in the include channel, all of the associated documents. And you can see the paths that we need to go here. That gives me the results immediately. And this is such a fundamental concept, has a huge impact. But at the base, this is such a simple scenario. Okay, more questions, please. And while I'm waiting for more questions, I would like you to remind you that if you haven't tried RavenDB, if you're just starting out, we're offering RavenDB on the cloud, including a completely free edition that you can start running and working with this. We also offer live demos. So this is a session like this, but instead of me talking, this is interactive. We are talking to you, we're explaining, we can hear your scenarios and hear everything about that. So you can go here and request something like that. We also have ongoing workshops. And the next one is in a couple of weeks, if I remember properly. And the next one would be RavenDB Basic. And we're very happy to invite you to that. And at this point, I think we run out of questions. I would like to thank you all for showing up for this webinar and have a great evening. Goodbye.